So good afternoon. It feels good to be here after a long time. And so I wrote here it's from NASSP, that's a title to space science. And I wrote, say, I was part of NASSP from 2005 up to 2010. Because although I didn't see it or I didn't hear someone saying it, part of the PhD funding also came from NASSP. So NASSP did not only sponsor honors and masters, but I benefited from the PhD funding. And there have been a number of things said about NASSP, and so I'll also give my own experience. And being that people are coming from lunch, I will not give a scientific talk. So I'll talk about the life experiences. So I finished my undergraduate degree in 2004, and I had heard about NASSP from the first person who attended NASSP in 2003, and that was Edward Giroux. And so during my applications to try and come to NASSP, he helped me a lot, and so I should publicly say thank you. Maybe I haven't said it enough. And so I arrived in Cape Town on the 28th of January 2005 to come and join honors. So I came 2 weeks late. The rest of my colleagues had already done a bit of introduction to summer school. And when I came, they had gone to Sutherland. They were on a trip to Sutherland. And so when I came, I arrived around midnight. It was my first time to Cape Town. I was confused. I didn't know where I was going. But I found a driver waiting for me when I got out of the terminal. He was called Trevor, so I can't forget him. And he had my name. Then I felt a bit at ease. And when he drove me here to Cape Town, he took me to a residence called Kopano. So my first night was at Kopano. And in the morning, very early in the morning, the first person to check whether I had arrived was Michelle Kluver. And later, at around 11, Lisa came. Then I realized, am I this important? Or So anyway, so my colleagues came from, this was my class of 2005 in honors. I think there's one person here, Zama. Zama is here. The rest are not here. Apart from one person here who is Phenhas, the rest had gone to Sutherland. When they came back, we continued with the introduction to summer school. And the person who was facilitating was the late Professor Tony. And so I went to attend for the first time, and he was asking questions, and the rest could answer, and I couldn't answer. So I said, maybe it's a first day, let me wait for the next day. The next day, we went back. It was the same experience. The third day, the same experience. And I asked myself, did I travel all this long to come here and fail? Because I was a bit confused. And so one afternoon, I went to Tony, and I asked him, has the course started? Because I was a bit confused. So he told me, no, John, don't worry, the course has not started. This is just introduction. And so the real course has not started. And so that was a relief on my side. And so but one of the questions that, now I have to try and remember my astronomy. So he was teaching us about HRR diagram, the scatter plot of stars that creates a link between their absolute magnitude and their stellar classifications. Yes, I think it was something like that. So we would identify white dwarfs, supergiants, giant stars. I knew none of that. Everything was sounding like a foreign language. But nevertheless, we went through the rest of the summer school, being comforted that the course had not started. And so we proceeded like that. And so what I want to talk about are success stories. Success stories in the sense that perhaps we miss some of the things. I think NASSP has succeeded beyond what we are saying. And so when I was preparing to talk, I saw this, there is a newspaper article that was put together by Patricia, Daniel, and Rose. It appeared in Sunday Times on the 15th of January, 2024. I know there's a lot of text, and it is deliberate. Number one is it captures my confusion in the first week of summer school, so there are so many words. But number two is that most of the words are not mine. But you can see the quotes from there, and every quote speaks to something that NASSP contributed. And so if you're interested, you can go and read this kind of article. It has a lot of details. But what captures your attention is you will see that 20 years ago, there were only 40 qualified astronomers. And by now, there are more than 200. So that in itself speaks a lot of volumes about what NASSP has done. The objectives are written there, and you can see that on each and every objective, NASSP has succeeded. I won't go through the quotations, but if we can narrow down from macro success and we go to micro success, and you look at what is happening at my own organization, within the research group, there are 6 research scientists who are direct products of NASSP. And that is out of about 10 to 11. So minus NASSP, perhaps to be understaffed or there will be something else, but that's a direct contribution of NASSP. And we have one head of space weather, she came from NASSP. We have a space weather forecaster, she came from NASSP. And of course, we have a number of postgraduate students. So that's one of the success stories. But earlier at the beginning, they talked about the funding that were given for us to do honors and masters and PhDs. And of course, we can have all the good plans, we can do the programs, but minus funding, nothing can be achieved. And so the funding that was provided, although it's written here that the bursaries covered basic needs, for those of us who needed that funding to just take one step forward, that was like planting a seed. And so when we see a flower flourishing, someone must plant the seed. And that seed is what NASSP planted, of course, through the funding agencies. And I think we should keep on appreciating the government support, especially the Department of Science and Innovation, that keeps on funding NASSP, through which we get more success stories. But if we ask us, why did we succeed? The NASSP participants, of the beneficiaries, why did we succeed? And why do we think that the current students will keep on succeeding? And you can think of a number of reasons. We had a very effective and very helpful administration. Earlier on, we were apologizing to Penny, because she was our administrator at that point, to say we are sorry for the headaches we caused. And we can do the same to Peter. And although it took 10 years to apologize, we have done it also. But those who came up with the concept of having NASSP did a lot of work. We had a lot of academic and social support. I remember the pizza clubs. We had a lot of expertise from all over the country. My lecturers, I saw them, Justin Jonas, then the plasma physics, he condensed that book, the entire book, into 3-week lectures. And we were talking, it was hard, but it was worth it. And of course, I saw others, David Berkeley, observation techniques, the others whom are all here. So we had ongoing support in almost every aspect, and we benefited from the diverse expertise. But you know that once you've done your honors and honors and masters coursework, you move to the other fields and you start doing research. There are those who chose to remain at UCT. There are others who went to other places. And one thing that perhaps we do not speak about is what I call a major factor of success, which is what Jonas and Jansen talks about and calls it an institutional lookout. So in his September 2023 newsletter, he talks of an institutional lookout as an underrated resource. So this is someone who is senior in any institution, maybe a supervisor or even a non-supervisor, but they identify young talents and they identify them from far, either in chemistry or philosophy. I think there is a definition there. And he demonstrates this with a nice example about a young historian who wins a prestigious scholarship to go and do some postdoc somewhere. And then the postdoc is very excited, goes to the head of the department, and then says, here is a very nice opportunity. And the head of the department says, so whom do you think is going to teach your courses when you've gone? And you've not been here long enough to accumulate that time to go away from the department. And of course, you can imagine what is going to happen to that kind of postdoc. But the one who is defined as an institutional lookout is going to say, let's go and celebrate. This is a very good opportunity. You go and celebrate, devices you know how to get the leave from the department, and then you move on. These are the people we don't celebrate a lot. And from our supervisors, from the lecturers, these played an important role for us to succeed. And they have a lot of characteristics, but all of them seem to be reading from the same book. They develop mentor-to-mentor relationship with those of us who needed that. They don't get paid for the work they do. If you are trying to write a publication, they will tell you, maybe this one does not fit here, it fits there. And depending on where they are directing you, that's one of the elements of success, because they have been there for some time, so they know where the work fits. And they are the ones who open all the opportunities for us to network and form our own partnerships and collaboration. And I'm very sure that none of us, irrespective of how talented we may be, would have made it without someone like that. That significant person who almost held you by hand and helped you along the way to succeed. And for my part, I know every one of you will have your own institutional lookout or someone you think did a lot of work for you to come up. For me, it was this lady who was our managing director, Dr. Yanni McKinnon. This slide is a bit busy. So where you see the red, I think it's a diamond, is where students that Rihanna supervised came from. And so you can see she supervised students in different African countries. But the important part is that most of these students were actually products of NASSP. They were coming from NASSP. And of course, learning from what she did, those of us who came from her own expertise kept the network and also supervised students from the other countries. So we expanded the network. And so this map, I'm using it as an evidence of NASSP as a continental driver of astronomy and space science. Because even when we had the International Year of Astronomy, those national point of contacts, most of them were products of NASSP. But NASSP has done way more than that. There was a time when the African Union decided to say, we need to write an African space policy and strategy. And so they sent letters to different ministries in different countries, and they put together, so every country would send whom they thought was an expert to go and write that kind of space policy and strategy. And so when we wrote that African space policy and strategy, which we divided into 4 domains, so there is Earth observation, satellite communication applications, space science and astronomy, and then navigation and positioning. When I looked at the room where we were, there was a presence of NASSP. There was other NASSP colleagues that we were sitting together in the room. Patrick is here, he was part of that group. And so NASSP has gone beyond that and has also contributed in formulating space policies and strategies that help the entire continent. Okay, so what do I do as a research scientist? It's written there, broadly speaking. I carry out research, but I do a lot of postgraduate training, honors, masters, and PhDs, and of course also with postdocs. And I always say, if that number 2 is taken out of my working conditions, I may as well quit what I'm doing. Okay, so this is the only science slide I'm going to talk about in this talk. So one of the things which I do, and I chose this one deliberately because I know everybody is going to associate with it, is that we do model development for space-based applications. And in this case, we are going to look at an application that relates satellite communications. So when you are doing your navigation or you are positioning, let's say you are driving around with your GPS or GNSS, the signal that you are getting from the satellite experiences a time delay. And that delay is proportional to electron content that it encounters, but it is also inversely proportional to the frequency of propagation. And so, and that electron concentration, you can integrate it along the line of sight, and what you get from that is a global figure like that. So that figure, you'll see it has a number of colors. Blue means low electron concentration, red is high electron concentration. What tells you is that at those areas where you have high values, you have a significant delay, a more delay than when you're in the blue area. And so part of the work that we do, that I'm involved in, is you look at a map like that, the global map, you will see some dots, but you also see some magenta stuff. But those dots represent, for example, where you could have an instrument that is observing this kind of electron concentration. Now, the role you have as a scientist is to develop a model that is applicable at each time of the day during all conditions. And because you do not have instrumentation, then you've got to do a bit of modeling. And so that's one of the work that I do. And when you are doing the modeling, there are three main ways you can do it. You can do the theoretical approach. So you can decide to solve the continuity, the energy and momentum equations from first principles. But number two is that you can also decide to combine empirical, so data-driven, and semi-theoretical. So combine those two approaches. And number three is that you can decide to say, okay, I'm going to use the data that's available, and I compensate for what is absent with something else. And that too will have to do also with what we call data assimilation, which is used a lot in meteorology. So in data assimilation, you have a background model that is uniform in both space and time, but you are not guaranteed of the accuracy. On the other hand, if you have those dots, you have a measurement, but you are not assured. So you have a measurement that is non-continuous in space and time, but you can quantify its accuracy. So in data simulation, you take the background model and you put on top the data to improve the performance of the system. So you can do that and you generate these kind of models, and these models can be used in real-time applications for positioning and navigation. And so one of the things that comes out is that you can specify, for example, here an electron density map, an electron density profile. So at each and every height, you can generate a map. And depending on where application is coming from, then you can use that appropriate map. So that's one of the things that I'm involved in. So what is the current status? Where have we been? And I'm using this one sort of as a, if I can call it, an accountability of NASSP investment. So since 2011, after I graduated with my own PhD, I've supervised 8 PhDs to completion, so they have graduated there somewhere else, also doing other things, 6 masters and 5 honor students. But one of the things that come out with growing up academically is that you get to do some things which some people may like and others may not like. And so each and every week I'm a source of either good news or bad news. And those bad news and good news come because I act as a scientific editor for different journals. So I edit for 3 journals, and here I'm showing on the radio science, and I'm also showing space weather. You can see radio science covers all from radio astronomy to quantum communications, and space weather is, of course, a journal of research and applications, and so it's mainly devoted to applications. So whatever you submit, you have to tell us what application does it have. So every week someone has to do it. When I'm clicking that email, especially to say, dear so-and-so, your work is not accepted, I feel bad, but I have to do it. That's part of growing up. For those who are still students, at some point you'll get to do this along in your career. And so what do I think is the future of NASSP? I think a lot has been said about this. NASSP has succeeded and continues to succeed because I think it encouraged cooperation as opposed to competition from the beginning. And the research that we were doing 20 years ago has changed, so there are new methodologies. And whether we are established scientists or emerging, we've got to embrace the trends. Otherwise, other things won't work. For example, machine learning. I even saw there is a department or a unit here that is dedicated to artificial intelligence. We've got to do that, whether we want or not. The world is moving forward. So one of the things that I was thinking is, would it be beneficial to consider introducing some interdisciplinary course at masters at NASSP, so that students at all the 3 nodes do that course? That could lead to different fields or different experts in different institutions collaborating and supervising students. That's what I would think about. Then we need to deepen our interinstitutional collaboration and cooperation with long-term vision, bearing in mind that we may not have immediate benefits. We can be comforted by the success of the students we supervise or we train. And of course, we've got to do it not because we want to do it, but because we have to do it for the benefit of the country and the continent. And so my last one maybe would be to say if it is possible to have 1 or 2 courses. I know different nodes do different courses, but we would encourage other collaboration between students who are the next scientists by having 1 or 2 courses that are done by students at all the 3 nodes, so that we encourage that kind of collaboration at an early age. Okay, and so maybe you can initiate or continue a program where those of us who came from NASSP, at each and every beginning of NASSP academic year, we can move and talk to students at different nodes from different fields so that they get a different feel of what people do when they get out of their academics. So thank you very much for listening to me. This is the end of my talk.